So I've worked on the knee now, and I've done something a little bit different. What I'm actually going to do is I'm going to create two morph targets for the same joint. Often what you'll find is that you can bend an elbow or a knee to its extreme position, fix it with the target, but because it's a linear target from now its original resting position all the way into the fully bent position, there's an intermediary stage where it doesn't look right. The morph target's at 50% at this point, and it's really not doing what it's needed. So what I find is often you actually need two morph targets for a joint that's going to have a lot of bend to it, and step through a process of doing about the 50% stage, correct it, add that, and then correct it again for the fully bent stage. So this is what I've done. I've also named my edit mesh modifiers here by right clicking on them, saying rename, so that we know which ones were which. I'm going to leave them all in the stack for the most part until I finish the character completely. I'm going to keep a version of them with all the targets built right in case I ever need to go back and adjust something or tweak something. I've got the edit meshes stacked up. I can turn them on and off as I need. So essentially what I've got is I've got the first one that does a bit of a change to it, and this was set up for frame 10. So this is doing a nice fix just to get the area not pushing into, starting to push the muscles down out of the way right away. It's doing a bit of stretch on top of the leg. You can actually see where the vertices were and where they currently are now when you have show end result on. So I'm just going to go ahead now, and at 10 I'm going to say add from stack and then turn off the edit mesh. And something to point out is you can see these yellow lines. These are vectors showing where the vertice is morphing to and where original positioning was. So as you step through, you can see where the vertice was originally and where it's now been moved to. This is a great visual guide so you know, again, partially which vertices you've moved and in which direction. You can see them even in the thigh here. I've decided to stretch the thigh down a bit further so that it moves with it. Now when I go all the way on to frame 20, I still have a lot of crashing happening and whatnot. I need to fix it again. So I'm going to turn on knee 2, which fixes the shape a bit more. It's pushing up the underneath of the leg a little bit. It pulls down some of the calf muscles a bit more and corrects some more in here. I didn't spend too long on it. And once again, I'm just going to simply say add from stack, and it adds another one in. And again, I can turn it off, and you can see the new vectors that are being shown. So now you can actually see as the vectors blend from one end to the next, you can see the vectors changing their angle and pointing in a different direction as the next target takes over, points them. So now I've got a reasonably well-deforming calf area here. It's still crashing into itself a bit. I could spend a lot more time working on that and getting it correct. A nice way to be able to work on the opposite side of the character is you can simply snapshot your mesh in the positions you need. Mirror the whole character. If you've got the character in a symmetrical pose, mirror the whole mesh over and just use that as a guide when you set up the other side. You can't pick and say add from node, and you can't pick from a mirrored node, because the mirrored node unfortunately is in a position where it is completely inverted, and your character as it morphed into it would actually fold itself inside out in a sense. The left knee would become the right knee and vice versa, so it would look very odd. So you can just use it as a reference. Once again, you can see all the vectors of where things are being pushed and pulled to in the arm as well. And that's going to help us solve a lot of those little problems. You can see the difference between now the left knee and the right knee when it goes down. I'll try and show it from the back here. The left knee is already starting to crash at the back at about frame 8, whereas the right knee that we've done work on is already beginning to push itself out of the way. And certainly up around frame 15, this is noticeably crashing through itself. Yet on the right knee that we've corrected, it really starts looking like it's being pushed down out of the way. You could add as many targets, maybe you wanted to use 3 if you wanted to get it really accurate, so that it stepped through 3 different stages of targets. That's the same with the new morph angle deformer, the skin morph in Max 7. You can add as many as you want at the given joint angles. And it also starts making it look like the leg is a little more alive. This leg looks quite fixed and stationary. It doesn't look like the muscle's doing anything. It just the joint's bending. So again, we could have come up with nice ways of fixing that, just the joint, but you really want to try and make sure that the muscles are actually flexing and bending a bit more like they might in a human body. We could have even done some work, like I said, across top of the thigh to stretch this down. You want to be careful of not going too far up driving the knee, because this area up here should be driven by the hip joint. And like I've said, I would avoid trying to use this system on something like the hip joint because of the 3 angles of rotation. You'll find that you'll fix it once and you'll say, hey, isn't that great? But then you'll try and fix it for the leg going backwards and sideways in a twisting state, and it won't work very well. So the next thing we're going to work on in this section is the bounce in the belly. So far, the way I've got this joint set up is I've got a bone. I happen to have parented to a point helper already as just an intermediary object. This one actually isn't even completely needed anymore. I generated another in the same place, but I orientation constrained this one between the 2 spine joints, this joint and this joint. So its orientation is based on an average of these 2. And that's kind of what I want. I don't want it parented to one or the other. I need it somewhere in between those 2 all the time. So it gives you a halfway point. So you can see it doesn't move 100% with the bottom one. This means my stomach's somewhere in between these 2 joints, and what I did is I simply weighted to this bone. So you can see that I've weighted a section around the stomach to that bone. And like I said, the tops of these stretch bones and the legs are also parented off to this bone, so they've got a bit of that area as well. So now I've got this nice flexy stomach area. What we want to do is we want to try and add a bit of automation to this so that it flexes a little more automatically. First thing I'm going to do is I want to create a point helper, and I want to put that point helper and align it up to the nub bone. And then I'm going to link this back to the joint that's orientation constrained using the link tool so that it rotates with it. Next thing I'm going to do is I'm going to add a spring controller. The spring controller is a position control, and it'll add a spring and a flex and a bounce to this node. I'm going to use the built-in tool position spring, and this basically just does the same as would have if you'd actually gone in and set the spring values up yourself. It also will jump it back to its parent, so I'm going to have to realign it up to the there we go. So now I've added it in here. Here's the spring. I'm just going to say open all, and then here are the dynamics rollouts for it. You can set a mass for it, and you can see it actually getting left behind now. As the character goes down, you can see it's no longer aligned to where it was. It's because the spring's taking effect. As it comes down, you can see it start to lag behind and bounce up and down. Let's increase the mass so we see that a bit more. And you can then see it settle to a stop there. Let's go through that section again. You can see it settle to a stop. Now this amount of bounces is way more than what we probably want. We can also just adjust this down maybe to 500. We also set a drag on this and increase the amount of drag so that it settles sooner. And you can see what kind of effect that has. Is it won't bounce as many times. It may only bounce sort of once and settle, and we don't want a whole lot of that in the stomach. We don't want it to just keep jiggling up and down. We want it to settle relatively quickly. In Spring Controller, you can also add other influence. Those other influences can be other objects around it that are moving. What's nice about this is right now the only thing that's driving the position of this is because it's linked back to the rotation of this point helper here. And it's using the position change it's going over and making it bounce up and down. We may want other things to actually drive this. And that might be the position of something else in the system that's going to push it up and down and make it work if some other part of the body moves without the spinal column bending. Because right now if I lifted a leg, it wouldn't actually do anything because this joint here wouldn't be rotating, therefore it wouldn't drive this. Yet we'd actually expect it to maybe bounce a bit as I lifted the leg up. So what we can do is we can say add springs. And add other springs to it. This now means that other things in the body are going to actually affect it. Now, as you can see, we've got probably way too much spring going on, because that object's bouncing all over the place. But at least now when you raise one of the feet and move it, it'll be moving that point helper around. You can see it gets very slow, by the way. Something to note about the Spring Controller, it is time dependent. And it will slow things down incredibly when trying to animate. So I'll show you how to turn it off for animation. It has to cache its result. So every single time you try and move the character at frame 140, let's say, every single time it has to recalculate this. It'll start from frame 0 and recalculate everything as you're trying to move the character. So very, very short amount of time, this can be completely unruly to use. So what you want to do is you want to turn it off while you're animating and then turn it back on for render times and seeing your tests. So let's actually adjust the amount down again with this. The other thing you can do is you can actually even adjust the amount of effect that each of the leg bones is going to have, and that's the tension on those items here. So we can actually decrease the amount that the legs have in effect, as well as set up dampening specific to each joint that's going to deal with it. Further down the list is external forces. We could actually add gravity here so that the gravity is always pulling on it and trying to pull it down. We're not going to need that at this point. We're going to leave that out. There's the start frame, and this is the start frame it starts to calculate from. The amount of iterations it uses to do the calculation. And then there's the effects, X, Y, and Z, XYZ. XYZ effect gives you sort of a multiplier on top, so let's just go to a spot where it's moving at this point, being pushed way up here. And it's in world coordinates, so you can see if I increase the amount of Z effect, it's increasing the amount of straight up and down effect. Let's just go to world so you can see what I mean. So that's the world Z up and down. X is across, and really you'd want your X and Y to be equal because the character could turn around the scene, but you can use set up the Z effect to be more or less based on gravity in a sense and have it help that. So you can say, well, don't go up and down quite as much as you do side to side, and now it'll only go up and down half as much as it would side to side in world space. If the character lies on its side, this is still sitting in world space though. I'm just going to leave them all set at 100 now. You really need to adjust this sort of thing once we're got some animation to test and to set it up for every shot possibly even. To get this to drive the bone, there's a couple of different ways we can do it. The simplest way is to add a IK solver to the bone. I'm just going to change the goal size to make it a bit smaller here, and then simply link the goal up to that point helper. Now you can see it's driving the bone up and pushing the stomach a long way up. Now I think we have way too much effect on it here. And there's this lag happening to it that's actually making the stomach lag a little bit behind. You can see it bounce a little bit there. Let's go back and do some adjustments to that. And let's take the tension down on the legs to a little lower. Oops. Let's increase the mass a bit more. And see what we get as a result. So you can now see it lagging further behind as it changes one direction or the other. You can see the whole stomach area now lagging behind a little bit and doing a little bit of settle at the end. Like I said though, it creates an incredibly slow rig at this point. If I try and move the character, and I have to remember we are also capturing here at the same time, but I almost can't move the character anymore, where it wasn't a problem to move before, it was moving in real time. And that's strictly because the spring controllers is just killing performance. You can see, even with my capture going, I can move this character reasonably well with a reasonably dense mesh on here, and a fair bit being calculated as far as calculating the elbow and knee joints and whatnot. It's because being at frame 0, this doesn't have to calculate much. So what you need to do is one of two things. During animation, you can turn iterations to 0. What that'll do is it'll actually dump the cache. It actually is going to dump out the cache as the iteration gets changed. So you're actually not carrying around any of that data. Move along to frame 140 again, and you can see we've got our speed back. This is the way you're going to have to animate and not see a little bit of flex, and then go and turn it on. The other way to deal with the is to actually turn the effects down. And this essentially has the same kind of effect. It will allow the speed to come back because there's no effect being added anymore. I tend to prefer to turn down the iterations just because I want to make sure that these values stay at whatever I happen to have set them at. And I'm not too concerned with losing the cache each time because it usually means that I'm animating. And as soon as you move or change the positions in the animation on the character, the cache has to be all regenerated anyhow. So turning off the iterations and losing the cache isn't really a big deal to me. It isn't like I'm losing anything that isn't going to have to be recalculated from scratch anyhow. So now what I've got is right elbow and right knee that's corrected or reasonably corrected. I've got a belly that now does a little bit of jiggle. I could have even added the same sort of thing into other bones. I could have put one into the chest bones here and had those things bounce a little bit for the chest area. I could have actually just skinned in an extra little bone here and linked it to it, and just had that bone just on a little bit of a jiggle to move the very nipple area and a surrounding area around it to bounce up and down. So you can do a fair bit with it, but again, you need to be able to shut it off at some point. It's relatively easy to script to be able to shut that off, and I'll show you that in the next stage, so that you can actually just generate a single button that will go in, turn off all of your spring controllers and turn them back on again, so that you're not having to hunt through your model, find them all, and do it each time you want to set up a preview render or something.